You can't afford to skip this. Why should you care really? Gain an understanding of AI and why it isn't so intelligent after all. Technology is a useful servant but a dangerous master. This famous quote by Christian Luslang encapsulates the dual-edged nature of technological advancement, a sentiment particularly relevant in today's discussions about artificial intelligence, AI. As the world buzzes with talk about AI, it's essential to strip away the layers of myth and apprehension surrounding it to understand its true nature and limitations. These days, everyone seems to be talking about AI. But what is it? What are its limitations? Should we be scared of what it might be capable of? The reality is that humans have always been inventors, ever since prehistoric times when we crafted harpoons for hunting. With the advent of agriculture, we moved on to creating pickaxes, sickles, and carts, tools to improve our efficiency and productivity. Just as those tools transformed our way of living, machines of the Industrial Revolution brought about another leap. Now, AI represents the latest frontier in this evolutionary journey of human ingenuity. In prehistoric times, tools were an extension of our physical abilities, enabling us to hunt and gather more effectively. When agriculture came along, we devised even more sophisticated tools, pickaxes to break the earth, sickles to harvest crops, and carts to transport goods. These innovations laid the foundation for settled societies and the rise of civilizations. Fast forward to the Industrial Revolution, machines took center stage, performing tasks at unprecedented speeds and scales. This shift brought both excitement and fear. People marveled at the power of these new inventions, while also fearing job losses and societal changes. Now, AI is the latest advancement in this lineage of technological innovation. Unlike the tools and machines of the past, AI operates on a different level, mimicking certain aspects of human cognition. But here's where the distinction is crucial: AI, despite its name, does not possess true intelligence. It lacks consciousness, emotions, and free will. AI systems are designed to process vast amounts of data and execute complex algorithms, but they do so without understanding or awareness. They are sophisticated tools, no more, no less. Take, for example, the chess-playing AI that can defeat grandmasters or the language model that can generate human-like text. These systems can perform specific tasks exceptionally well, but their intelligence is limited to those tasks. They follow predefined rules and patterns, learning from data to improve their performance. Yet, they do not understand the game of chess or the intricacies of human language, they simply execute programmed instructions. This distinction is vital in dispelling the myth that AI could one day develop human-like consciousness or intentions. Understanding AI's limitations is crucial for harnessing its potential while avoiding misuse. AI can provide solutions that, while not perfect, are often good enough for practical purposes. For instance, in medical diagnostics, AI can analyze images to detect anomalies with high accuracy, aiding doctors in making better decisions. However, these solutions are based on patterns in the data they've been trained on and are subject to biases and errors inherent in that data. Hence, human oversight remains essential to ensure the reliability and ethical application of AI technologies. As we look to the future, the role of AI will continue to expand, integrating deeper into various aspects of our lives. The key is to focus on leveraging AI to complement human capabilities rather than replace them. This involves setting clear ethical guidelines and regulatory frameworks to govern AI development and deployment. By doing so, we can ensure that AI serves humanity positively, enhancing our abilities and helping to solve complex problems without overstepping its bounds as a tool. In conclusion, AI is a remarkable testament to human ingenuity, embodying our drive to push the boundaries of what's possible. Yet, it remains a tool, devoid of the consciousness and free will that characterize true intelligence. As we navigate this new technological frontier, it's important to remember Lang's words and ensure that AI remains our servant, not our master. By understanding its capabilities and limitations, we can harness AI for the greater good, ensuring it enhances our lives rather than diminishes them. To our valued audiobook listeners, we appreciate your continued engagement with our content. If you've found value in our discussions on AI and other topics, we kindly ask you to consider subscribing to our channel. Subscribing keeps you updated on new releases and helps our channel grow, allowing us to produce more high-quality content for you. Additionally, liking and sharing our audiobooks with others who may benefit from them would be greatly appreciated. Your support is crucial in ensuring the continued success of our channel. Stay tuned for more nuggets of wisdom, and until next time, happy listening. About the author. Nicolas Sabarat is a professor of computer science at Université Paris-Saclay. He holds a doctorate in artificial intelligence and has supervised extensive research in the field. Understanding Artificial Intelligence, 2021, aims to demystify the subject of artificial intelligence, AI, for everyone, including those without an IT or mathematical background. It provides a basic understanding of how AI works and explains why it sometimes makes mistakes or offers imperfect solutions. What exactly is AI? Let's clear something up right from the start. Computers are machines, and AI doesn't make them intelligent. They still do only what we tell them to do. As Alan Turing, a pioneering figure in computing, once said, a computer would deserve to be called intelligent if it could deceive a human into believing that it was human. Computers have evolved significantly over time. Initially, they were simple calculators that dealt with numbers and math. Gradually, they advanced to handling words, images, and sounds. Today, we have sophisticated devices like smartphones that can listen to our requests and perform actions based on them. These capabilities are made possible by algorithms, which are essentially step-by-step instructions for solving problems. A familiar example of an algorithm is the process used to add large numbers together in school. Think of an algorithm as a recipe that a cook follows to create a dish. Similarly, a computer follows the instructions in an algorithm to produce a desired result. In the early 19th century, Charles Babbage developed the first machine capable of following algorithms. By 1936, Alan Turing demonstrated that computers could theoretically follow any algorithm, no matter how complex. This laid the foundation for modern computing and the development of AI. Today, the term AI programs might be more accurate than just AI. Essentially, AI applies an algorithm written by a human to produce responses that seem intelligent. Programmers also use AI to write programs through a technique called machine learning. However, this term can be misleading. The way AI generates new programs depends heavily on the quality of the data it receives, adhering to the old adage garbage in, garbage out. Understanding AI's nature and capabilities helps demystify the subject and dispel common misconceptions. While AI can perform complex tasks, it remains a tool created and controlled by humans. This understanding is crucial as we continue to integrate AI into various aspects of our lives, ensuring we harness its potential for good while avoiding pitfalls. By grasping the basics of AI and its limitations, we can better appreciate the technology's role in our world and its potential impact on the future. Whether we're using AI in our daily lives or exploring its applications in various industries, it's essential to remember that behind every AI system is a human-designed algorithm, guiding its actions and outcomes. So, is AI really intelligent? That's a very good question, but to answer it, we first need to understand what intelligence is. And that isn't as easy as you might think. Is it the opposite of ignorance? Consider this: if you were asked when the city of Istanbul was founded, would you know? Most likely not. But does that make you unintelligent? And would you define Wikipedia as being intelligent because it can tell you the answer? It's the 7th century BCE, by the way. What about the ability to do complicated math? Can you give the answer to 24,357 by 527, for example? You probably can, given time, but a simple calculator can do it much faster. Is that calculator more intelligent than you? In reality, neither the calculator nor Wikipedia is intelligent. Computers may be capable of dealing with tasks associated with calculation and memory, but they're not intelligent by human standards. After all, humans can reason based on past experience, make decisions in situations too complex to describe accurately to a computer, learn new skills, have ideas, and communicate using complex and abstract ideas. So how can we assess the intelligence of a computer? Well, remember Turing? He came up with what is known as the Turing test. Here's how it works: a human is in one room and a computer with AI in the other. You can communicate with both using a keyboard and screen for each, but you don't know which is connected to the human and which to the AI. A delay is built in to ensure you can't tell which is which from speed, but only from the responses themselves. The test is to determine how close the AI can answer in a manner that resembles human intelligence. Since 2006, there's been an annual competition to determine the chatbot which comes closest to fooling the judges. The judges, though, are very adept at getting the chatbots to respond incorrectly, some needing only 5 questions to identify the AI correctly. But the Turing test is, in any case, flawed. If we want to test the intelligence of an AI program, we should really test its performance in the task it has been developed to perform, playing chess, for example, not whether it can have a philosophical discussion about chess. We should remember that in creating AI, we're not trying to create an artificial human. It was Edsger Dijkstra, a computer scientist, who summed up the difference between human intelligence and AI rather neatly when he said, "The question of whether machines can think is about as relevant as the question of whether submarines can swim." Machines don't think. We might think they're intelligent, but they're not. They follow pre-programmed algorithms and use vast amounts of data to generate responses that mimic human-like interactions. While they can perform specific tasks extremely well, such as playing chess or recognizing faces, their intelligence is fundamentally different from human intelligence. It's limited to the data they've been fed and the algorithms they follow. So, while AI can seem impressively smart, it's important to remember that it's not truly intelligent in the way humans are. What is an AI algorithm? So now that you know AI isn't intelligent in the same way humans are, let's take a closer look at what AI algorithms actually are. You might be surprised to learn that they're nothing special. They're just like the cooking recipes we mentioned earlier, step-by-step approaches to solving tasks. It has taken years of research to develop them, and there's no standardized approach, meaning there are many different AI algorithms. Despite their variety, they share some common elements designed to overcome the limitations in memory and processing capacity of computers. To put this in perspective, a personal computer from the 2010s can perform billions of additions per second. However, if a task requires 10 billion steps, you'll have to wait a few seconds for the result. If it needs a trillion steps, you might wait 15 minutes. And for 100 trillion steps, you'll need a whole day. That 100 trillion might seem like a lot, but the number of operations required can escalate quickly. For instance, consider a school head who needs to schedule students, classes, and teachers. If the school has just 10 rooms with 15 classes, each hour presents around 3,000 possibilities. For an 8-hour day, that means 6 billion possibilities. That's 6 with 27 zeros. Processing each possibility with a computer, even one performing a billion operations per second, would take far too long. These computational limits are crucial to AI and are known as complexity. We need to distinguish between the complexity of algorithms and the complexity of the problems the algorithms are solving. The complexity of an algorithm depends on the size of the problem and the amount of data required. The complexity of the problem itself is the minimum number of operations needed to solve it. This is often a theoretical number, and sometimes less elegant algorithms with higher complexities are used to find the best solution. Does this sound complicated? Let's simplify it. Some problems have a theoretical complexity so high that, even with the best algorithms, the number of operations required far exceeds what any future computer could manage, even if it were millions of times faster. So, when it comes to AI, the algorithms used are sometimes less than perfect. A face recognition algorithm might make a mistake, or a chess algorithm might make the wrong move, but often they provide the best possible solution in a reasonable amount of time. In essence, AI algorithms are sophisticated tools that help us manage and solve complex problems within practical time constraints. They are the result of balancing theoretical efficiency with practical applicability, ensuring we get usable answers without waiting indefinitely. While they might not always be flawless, they are incredibly powerful in handling tasks that would otherwise be impossible for humans to manage manually. How does AI come up with a solution? There are many AI methods used to solve problems. As we've established, these methods are not inherently intelligent and don't always provide the best solution to the problem at hand. Nicholas Sabret offers various examples of these methods, but let's focus on a fundamental AI method called exploration. Imagine you're in Alexanderplatz, Berlin, and want to visit Museum Island. You could plan your route using a map, noting street names and turns, utilizing your intelligence. While most of us can do this, some might get lost. Thankfully, we have GPS to assist us. But how does GPS work? GPS determines your location by referencing signals from 28 satellites and calculating the time it takes for each signal to reach you. With this data and a map, GPS calculates a route from your current position to your final destination by creating a graph of all the points you need to pass through. This might sound straightforward, but it's more complex for a computer, which must consider all possible neighboring points as it progresses, storing the others in memory. Alternatively, it could spiral out from the starting point. Neither method is particularly efficient, and as the area to be considered grows, it becomes almost impossible to solve the problem in a reasonable time. This is where heuristics come into play. A heuristic algorithm approximates the solution. In our example, it would involve instructions like go in roughly the right direction and stay on the main paths. Using our cooking analogy, instead of weighing exactly 1 ounce of butter, you might just cut a piece that looks like an ounce from an 8-ounce block. It's not precise but close enough. Therefore, the route suggested by GPS to get from Alexanderplatz to Museum Island may not be the best possible route, but it will be good enough and get you there efficiently. This practical approach is a hallmark of how AI operates, by providing workable solutions within a feasible timeframe, even if they aren't the perfect ones. AI leverages exploration and heuristics to navigate the vast possibilities in problem solving. This combination allows AI to handle complex tasks, such as navigation, without requiring excessive computational resources or time. By approximating solutions, AI systems can deliver functional results that are practically useful, if not always perfect. In summary, AI's strength lies in its ability to process large amounts of data and use heuristics to provide good enough solutions. This pragmatic approach ensures that AI can assist in everyday tasks effectively, demonstrating its utility as a sophisticated tool in our technological arsenal. Where's the future of AI heading? You might be wondering if we'll ever build a machine that's truly intelligent, one that learns as a child does, is aware of the world around it, can feel emotions, and with which we can build a future. This question has been a topic of debate among researchers, and while some believe it's possible, Nicholas Sabarat suggests that there's no current evidence to support this. In the 1970s, John Searle coined the term strong AI to describe AI that perfectly imitates human intelligence. Conversely, weak AI refers to AI designed for specific tasks, such as winning at Go. Despite the term, weak AI systems are incredibly powerful, often surpassing human capabilities in their designated tasks. Strong AI can be further divided into general AI and artificial consciousness. General AI refers to a machine capable of solving various problems across a wide range of domains, like obtaining a university degree, passing the Turing test, and performing tasks in unfamiliar settings. Artificial consciousness, on the other hand, would imply that a machine is aware of its existence and surroundings. Defining and testing for consciousness and machines, however, remains a complex and unresolved issue. So, are we on the brink of achieving either general AI or artificial consciousness? The honest answer is that it's uncertain. While AI continues to make significant strides, such as outperforming humans in games like Go and poker, it still struggles with more complex tasks like video games or nuanced decision-making in fields such as medicine and human resources. Sabarat argues that the human factor in these tasks is challenging to replicate and that AI systems can be easily manipulated with antagonistic data. Should we worry about AI enslaving humanity as depicted in science fiction? For now, the answer is no. Weak AI, designed for specific tasks, lacks imagination and creativity. While strong AI might become a reality someday, we are far from achieving artificial consciousness. The primary concern at present is the misuse of AI. For instance, in a world where social media dominates information dissemination, a totalitarian regime could potentially control the information flow, leading to significant societal impact. Additionally, AI has been used for malicious activities, such as hacking cybersecurity protocols. However, these actions are not spontaneous. AI must be programmed for such purposes. The potential for AI misuse underscores the need for ethical guidelines and regulations to prevent harmful applications. Regardless of the future trajectory of AI, one thing is certain: AI has propelled humanity toward a deeper understanding of itself. By exploring how humans perform tasks and striving to replicate or enhance these processes, AI has highlighted our strengths and limitations. As Sabarat posits, perhaps the greatest gift AI has given humanity is the opportunity to better understand ourselves. Summary. In our exploration of artificial intelligence, AI, it becomes clear that the term intelligence as applied to machines is more about mimicking human-like tasks than possessing true consciousness or understanding. AI operates within the boundaries of algorithms, meticulously following instructions crafted by human programmers. These algorithms, akin to recipes, guide AI in processing vast amounts of data and executing tasks from recognizing speech to playing strategic games like chess or Go. However, despite their impressive capabilities, AI lacks the inherent reasoning, creativity, and adaptability that define human intelligence. One of the key insights gained is how AI utilizes heuristic algorithms to navigate complex problems. Unlike precise mathematical calculations, heuristics allow AI to approximate solutions based on general rules or rules of thumb. This approach sacrifices perfection for practicality, aiming for outcomes that are sufficient for the task at hand. Thus, while AI may not always deliver flawless results, it consistently offers solutions that are adequate and timely, illustrating its utility in various fields from healthcare diagnostics to logistics management. The notion of AI achieving consciousness, akin to human awareness and self-reflection, remains a distant prospect. Current AI, categorized as weak AI, excels in specific domains but lacks the holistic understanding and introspective capabilities that characterize human consciousness. Concepts like strong AI or artificial consciousness, envisioned by some, pose profound philosophical and technical challenges that researchers continue to grapple with. Nonetheless, the potential misuse of AI for nefarious purposes underscores the ethical considerations surrounding its development and deployment. Looking forward, the trajectory of AI holds promise and peril in equal measure. While advancements in machine learning and neural networks continue to revolutionize industries, concerns over data privacy, algorithmic bias, and societal impact loom large. The rise of autonomous systems and AI-driven decision-making raises fundamental questions about accountability and governance. The ongoing dialogue about AI's future underscores the need for responsible innovation and ethical frameworks to guide its evolution. In conclusion, while AI may not be the sentient beings of science fiction, its transformative impact on society is undeniable. Understanding its capabilities and limitations empowers us to harness AI responsibly for the collective benefit. As we navigate this technological frontier, it's crucial to remain vigilant and proactive in shaping policies that prioritize human values and societal well-being. In the words of Alan Turing, we can only see a short distance ahead, but we can see plenty there that needs to be done. Your engagement with our exploration of AI is invaluable. If you haven't already, consider subscribing to our channel for more insights into the fascinating world of AI and technology. Your support not only helps us grow but also encourages us to delve deeper into these critical topics. Like, share, and spread the knowledge with others who might find it enlightening. Together, let's continue to explore and understand the complexities of AI. Thank you for being part of our community.